So guys, here in this video we will discuss about that how can we find the probability distribution function for any continuous case. So now, and I will try to explain that how to find the probability distribution function for the continuous case by one or two example. See here that this is given that find the probability distribution function of the following PDF f of x is equal to mod x, which is defined over -1 to 1. So see here that here if we consider the function that is f of x is equal to mod x, and here we can write it that is minus x when -1 less equal to x less than 0 and x when 0 less than x less than 1, and the PDF means the probability density function, and we know that a function is said to be probability density function. A function f of x is said to be probability density function if minus infinity to infinity f of x dx is equal to 1. So see here that if we discuss it here, that is only the function is defined over -1 to 0 and 0 to 1, otherwise it is 0. So -1 to 0 minus x dx plus 0 to 1 x dx. So from here we will get minus of half x square -1 to 0 plus half x square 0 to 1, and if we simplify this we will get half plus half is equal to 1. So now we can say that this function is a probability density function, so it is verified. So now we can find the distribution of this probability density function. So now how can I find the distribution function? The distribution function mainly defined by f of x is equal to minus infinity to x f of t dt. So now here the question is that how can we find it, and also remind one thing that distribution function is always cumulative. Distribution function is always cumulative. Is always cumulative. So now in the next slide I want to show you that how can we find the distribution function. So how can I find the distribution function? The distribution function is defined over total the real line minus infinity to plus infinity. And here see that the question is given that f of x is equal to minus x less than 0 and x whenever 0 less than x less equal to 1. So here we can define it. This is the point -1, this is the point 0, this is the point +1. So now you can see that when if we consider minus infinity x less than -1, then the density function f of x is equal to, we can write minus infinity to x f of t dt. See here that in this region the function is not defined, so we can say it is 0. And in the next, which one is given? That is -1 to 0. -1 less than x less than 0. So in this case f of x is equal to, we can write minus infinity to x f of t dt, and here we can write it, since we say that the distribution function is cumulative, so we can write it minus infinity to -1 f of t dt plus -1 to x f of t dt. So here it is 0 minus -1 to x plus here it is minus t dt, since it is defined f of t is equal to minus t. Then now if we simplify we will get, this is minus half t square -1 to x, and now if we simplify we will get the value will be half of 1 minus x square. And now if we find that minus 0 less than x less than 1, then f of x, it will be minus infinity to x f of t dt, and we can write it by like this, then minus infinity to 0 f of minus infinity to -1 plus minus 1 to 0 f of t dt plus 0 to x f of t dt. So here this is the 0 minus 1 to 0 t dt minus t dt and plus 0 to x t dt. And if we simplify, we will get from here, that is this one we will get minus half, this is plus half, plus half x square, that is half of 1 plus x square. And at the last we have to find the point of 1x greater than 1. So how can we find it, the x greater than 1? So here when we say that x greater than 1, or we can say 1 less than x less than infinity, the probability density function f of x is, it must be of the form minus infinity to x f of t dt. And we can write it that minus infinity to minus 1 f of t dt plus minus 1 to 0 f of t dt plus 0 to 1 f of t dt plus 1 to x f of t dt. And see here that in the given question, it is also given f of x is equal to minus x 0 and x 1 0 less equal to x less than 1. So from here we can say that for this one, this is 0, this is 0, and for minus 1 to 0 it is minus t dt plus 0 to 1 t dt, and if we simplify we will get half plus half is equal to 1. So now the probability density function, probability distribution function for the probability density function f of x is equal to mod x, that is f of x is equal to 0 when minus infinity less than x less than minus 1. This is half of 1 minus x square minus 1 less than x less than 0, half of 1 plus x square when 0 less than x less than 1, and 1 when x is greater than 1. So this is the probability distribution function of a continuous function f of x is equal to mod x, which is defined over minus 1 less equal to x less equal to 1. So now similarly we can solve another one problem here. This is also given that find the probability distribution function on the function probability density function 6 into x minus 1 2 minus x, which is defined over 1 less equal to x less equal to 2. So f of x is equal to 6 into x minus 1 2 minus x. So first of all here we have to check that it is really a probability density function. So here we have to just check that between 1 to 2 f of x dx is equal to 1 or not. That is 6 into x minus 1 2 minus x dx, that is 6 into 1 to 2, we will get 2x minus 2 minus x square plus x dx. So 1 to 2 we will get, this is 3x minus 2 minus x square, and if we integrate we will get 3 by 2x square minus 12x 1 to 2 minus 6 by 3 x cube 1 to 2, and if we simplify it 1 to 2, I think we will, that is I just simplify it here, that is 239 9 into 4 minus 1 minus 12 into 2 minus 1 minus 2 into 8 minus 1, that is 27 minus 12 minus 40, that is equal to 1. So this is a probability density function. So now we can easily find, now we can able to find the probability distribution function of this function f of x is equal to 6 into x minus 1 into 2 minus x. So now let us try to find it. So how can we find? That is, we know that the definition of the probability distribution function minus infinity to x f of t dt. and here region is defined over 1 less equal to x less equal to 2. So now when we say minus 1 infinity x less than 1, so f of x will be minus infinity 2x f of t dt, and it will be 0 because here the function is not defined, because the probability density function 6 into x minus 1 2 minus x, which is defined over 1 less equal to x less equal to 2. Now if we set the region 1 less x and x less than 2, this will be minus infinity 2x f of t dt, and we know that the distribution function is cumulative, so here we can write minus infinity to 1 f of t dt plus 1 to 2 1 to x 1 to x f of t dt, and here 1 to x by this region, this is defined by this, and this is 0, so 1 to x 6 into x minus 1 into 2 minus x 1 minus t, sorry, t minus 1 into 2 minus t dt. So this is 6 into 1 to x, we will get 3t minus 2 minus 3t minus 2 minus t square. 3t minus 2 minus 2 minus t square dt. So now we have to integrate this one. So how can we solve it now? We have to solve this integration. So now here I create a new slide. That is, we get 6 into 1 to x 2t minus 3t minus 2 minus t square dt. So now if we simplify, that is 6 into 3 by 2 t square minus 2t minus 1 by 3 t cube 1 to x. That is, we get now from here 6 into 3 by 2 x square minus 1 minus 2 into x minus 1 minus 1 by 3 x cube minus 1. And if we simplify now, so from here what we get, 2 into 3, that is 9 x square minus 1 minus 12 x minus 1 minus 2 x cube minus 1. So from here we will get, this is 9x square minus 9 minus 12x plus 12 minus 2x cube plus 2. And if we simplify, we will get, the value is 5 minus 12x plus 9x square minus 2x. So this is the probability distribution function, and now when x greater than 2, the density function f of x f of t dt. So here we will get minus infinity to 1 f of t dt plus 1 to 2 f of t dt plus 2 to infinity f of t dt, and here the value is 0, and already we get 1 to 2 6 into t minus 1 into 2 minus t dt, this value is 1. So now we can write the distribution function. This is 0 minus infinity less than x less than 1, 5 minus 12x plus 9x square minus 2x cube for 1 less than x less than 2, and 1 when x is greater than 2. So I hope you understand that how can you find the probability distribution function for the continuous case. So thank you for watching the video.